It is given two complex numbers, z1 and z2. N is positive integer. Find the value of z1 cubed. So you can see that z1 is given in the modulus argument form. It also can be rewritten as 3 times cosine of 3 pi over 4 plus I sine of 3 pi over 4. It's also the modulus argument form. And if you calculate, it's not required here, but in general, if you calculate the values of cosine and sine, and when you expand, you get a complex number to be given in the form x plus iy, which is called the Cartesian form. And also, it can be written as 3 multiplied by e to the power of I times 3 pi over 4. And this value, it's the modulus, it's the distance from the origin when you represent a complex number on the organ diagram, where it's real part, it's imaginary part, and some complex number with coordinates x, y, and this distance from origin, and you can see that it can be found as x squared plus y squared. It's modulus or mod of z, and it's always positive. It always must be positive. And this is the argument. Argument is angle, and notice that it's absolutely similarly to the unit circle. The starting point of 0 is here. Positive angles in this direction, negative in this direction, and you can find what this small angle. It will in general it will be the supplementary angle. And finally, from the picture you can give the answer about the argument. So you can find small from what tangent, for example, tangent of this angle is what y over x, and you can see 0 is here, so argument is directly this angle. If a complex number is somewhere here, you can find this small angle as what tangent, and you take absolute values of y and x, and you can find this small, then argument it will be pi or 180 minus this small angle. If it's in the third quadrant, you can find again, you can take absolute values, positive values of x, y, find the small angle, and then argument it will be what 180 or pi plus this small angle. And if a complex number is in the fourth quadrant, again you can find this small angle, and argument it will be 2 pi or 360 minus this small angle, or it just negative this small angle, because it's in clockwise direction. In clockwise there are negative angles. And if we need to raise to some power, or if we need multiplication or division, it's useful to use this form. It's called the exponential form or the Euler's form. Why? Because z1 cubed becomes 3 e to the power of I 3 pi over 4 and cubed, and it becomes what product to some power. It's what this 3 cubed and e to the power of I 3 pi over 4 and also cubed, but it looks like 2 to the power of 5 cubed, and it's what, it's 2 to the power of 3 times 5, it's 2 to the power of 15, and here it's absolutely the same, so it becomes e to the power of 3 pi over 4 and multiplied by 3, so it becomes 27 e to the power of I times 9 pi over 4. And notice that argument theta must be from negative pi to pi, and notice that if you consider any point, if you make or if you do one complete revolution or any number of complete revolution, any number of 360 degrees or 2 pi, you get absolutely the same point. So now it will be absolutely the same complex number. So in general we can add or subtract any number of 2 pi or 360. And you can see that 8, 9 over 4, 8 pi over 4 is what, 2 pi, so we can just subtract 2 pi. So 9 pi over 4, it's what, 8 pi over 4, which is 2 pi plus pi over 4. And it's just the same as just pi over 4. So you can add or subtract any number of 2 pi or 360 and it will be absolutely the same argument. It will be equivalent. So it's the same as 27 times e to the power of I pi over 4. In general, if it is required to get the answer, some value, actually you may calculate using a calculator, and that's all, or it's not required here because the answer must be in such form. But in general, if you need to calculate it, you may use just a calculator, or it's the same as 27 cos what, pi over 4 plus I sine pi over 4. And you can see how to convert in the Cartesian form. 27 cosine of pi over 4, it's what, 45 degrees, it's root 2 over 2 plus I root 2 over 2. And if you expand, you get in the form x plus I y, if required. But here it's not required. The final answer must be in such form where i's modulus must be positive and theta is, or must be from negative pi to pi. The next, find the value z1 over z2 to the power of 4 when n is 2. So it becomes z1, what is z1? 3, but again I will use the Euler's form, the exponential form, because it will be more useful. So it's 3e to the power of I 3 pi over 4 divided by z2. What is z2? It's 2. C is again, it's e to the power of what, n is 2, so it's 2 pi over 16 or pi over 8. I pi over 8, and then to the power of 4. Definitely you may raise to power of 4, you can raise the numerator to the power of 4 and denominator to the power of 4 and then divide, or we can divide and then raise to the power of 4, it doesn't matter. So it seems that it will be more easier to divide firstly, so it becomes what, 3 over 2 and e to the power of what? It's like 2 to the power of 10 divided by 2 to the power of 4. It's what? 2 to the power of 10 minus 4. So it becomes e to the power of I 3 pi over 4 minus pi over 8 and then to the power of 4. So it's 3 over 2 to the power of 4 and e to the power of what? Common denominator is what? 8, so it's 6 pi over 8 minus pi, it's 5 pi over 8 and also to the power of 4, and it's what, 81 over 16 and e to the power of I 5 pi over 8 multiplied by 4, and it's, you can see 5 pi over 2, and you can see it's what, 2.5 pi or 2 pi plus pi over 2, and again we can add or subtract any number of 2 pi. It's required because theta must be from negative pi to pi. now it's 2.5, but if we subtract 2 pi, it will be equivalent and as required, so e to the power I pi over 2. So it's in the form as required. And the next question, find the least value of n such that z1 times z2 is real and positive. It's quite typical question. You need this complex number to be represented in the modulus argument form, like r cosine plus I sine. So let's consider this product. So this product becomes 3, and again I consider the Euler's form firstly, so it becomes what, 3e to the power of I 3 pi over 4, 3 pi over 4 multiplied by 2 e to the power of I multiplied by n pi over 16, n pi over 16. Let's simplify, so it becomes 6 and e to the power of, it's just the sum, because it looks like 2 to the power 5 multiplied by 2 to the power 3, it's what, 2 to the power of 5 plus 3, absolutely the same. So it becomes 6 times e to the power of I 3 pi over 4 plus n pi over 16. And for such type of questions, when you need real or just real or real positive, we need represent it in the form, in the modulus argument form, like this: 6 cosine of 3 pi over 4 plus n pi over 16, because it's argument, plus I sine of 3 pi over 4 plus n pi over 16. And to be real, this must be 0. When the 0, you can see that it will be a real number. To be real, sine of 3 pi over 4 plus n pi over 16 must be 0. And we can consider unit circle xy. You remember that it's coordinates 1, -1, -1, 1, and sine, if we consider any angle on the unit circle, x coordinate is cosine, y coordinate is sine. So sine to be 0, y coordinate must be 0. So solutions are this point and this point. We can consider these two solutions separately, like what, 0 degrees, but again you may do absolutely any number of full revolutions. So general solution is 0 plus 2 pi k and what, pi plus 2 pi k, but it will be more useful to combine these two solutions and write one solution instead of two solutions to be considered separately. How to do that? You can see that you will move between two consecutive roots by adding or subtracting pi, and we can take any particular solution, for example 0 pi 0, it will be more easier, plus pi k. So you can see that if you consider any number of k, you will move between roots, and you can get absolutely any root for some specific value of k. So sine is 0, general solution is, we just copy this argument, and general solution is pi k, where k is any integer. Integer is 0, 1, 2, 3, 4, also negative, negative 1, negative 2, and so on. And then let's solve this equation for n. How to solve it? We can see that we can divide each term by pi, and let's get rid of denominators. Let's multiply each by 16 to get what? If we multiply this by 16, 16 over 4 is what? So it's 12 plus n is 16k. And n becomes 16k minus 12. And since n should be what? N are positive integers. Positive integers, what does it mean? 1, 2, 3, 4, 5, and so on. Let's write solutions. So but k may be 0, 1, 2, and so on, and also negative, negative 1, negative 2, and so on. Let's start with 0. So we can see that when k is 0, n is negative 12, but we need n to be positive integer, and when k is negative, we'll get negative values of n, but we need positive values of n. So when k is 1, we can see that n is 4. It's positive, it's the first positive integer. When k is 2, it's what? 32 minus 12, it's 20. It's 20. The next, it's when k is 3, it's what? 48 minus 12, it's 36, and so on. We need the least positive n in general, so we can write a few. Why? Because if a question would be just real without this plus, just to be real like this, answer would be 4. For n is 4, this product will be positive, will be just real, because sign becomes 0, and it will be some value without I. But question is this complex number to be not just real, but real and positive. So and n must be the least. So we start from the smallest value of n and just check this complex number. We substitute n to be 4. Definitely it's 0. You may check that it's 0. And what about this value? It becomes cosine 6 and cosine of what? 3 pi over 4 plus 4 pi over 16, or pi over 4, and together it becomes what? 4 pi over 4, which is cosine of pi, but cosine of pi, it's negative 1. So for n is 4, it will be a real number, but negative. And definitely the answer it will be 20, but let's check. Just from experience, you may remember that for such type of questions, it's enough only 2 n values, because if the first is not for the first it becomes negative, definitely for the next it will be positive. But let's check. So when n is 20, again sign gives 0, so it's real, and let's check, it becomes 6 times cosine 3 pi over 4 plus what? 20 pi over 16. We can divide by 4, it's 5 pi over 4, and together it's 8 pi over 4, and it's 2 pi, and cosine of 2 pi, it's 1, so it's positive, it's plus 6. Actually a number, this complex number becomes just 6, but it's not required here, so the answer is 20. For n is 20, z1 times z2 is real and positive. And that's all for this question.